to like, okay, it's assumed I have to follow through and do this one. With your two-way, you're just like, okay, it's robust, it should be okay. You don't really have to worry too much about it per se. Like you would just acknowledge it as a limitation. You could adopt a more stringent p-value, but nothing pressing. It's not really going to change how you interpret the results of your test. Okay, so we're going to go through the SPSS. So essentially this time when we go through, we're going to go to Analyze General Linear and go to Univariate. Here you will see some information. Right off the bat, what I'm going to tell you is that this is not valid for your final exam. It's just here as an example because the data that we had to make this example only had 3 conditions. So essentially, what you're going to do is you're going to move your independent variables into your fixed factors and your dependent variable into your dependent variable box. And you do not need to click your post hoc box. Essentially, what a post hoc test is an analysis of the differences between the groups. When you guys looked at your t-test, you didn't run any post hocs because you're comparing 1 and 2. There's only one difference, the difference between 1 and 2. When you run larger scale ANOVAs, like 3-way ANOVAs, you have to compare the difference between 1 and 2, 1 and 3, and 2 and 3. Essentially, this box allows you to do that. The system will do it for you. But your final exam has two condition variables. Post hocs are not necessary. Your information will come from your descriptives, just like it did for your t-test. This is literally just there. I don't want to like psych you out. It's literally just there. When you guys read things and you want to know about it, or if you guys take honors thesis, for example, you guys are going to want to know it because ANOVAs are super, super important. So, yep, right here. You only need post hocs for IVs with 3 or more levels. Otherwise, the info comes from your descriptives. Next thing we're going to do is we're going to go into our plots box. You are going to move your IV with the smallest number of categories into separate lines, as well as the most categories into horizontal axis. Plot twist, you guys have 2 2x2s. So like, it doesn't matter. Whatever it is that you guys want to put in, there's no right way or wrong way because there's literally 2 variables. This also isn't a formal rule. It's literally just to help it become easier for you to interpret. So my personal preference is if I'm ever working with gender, I always make gender my separate lines. I can see a pink line for females and a blue line for males, and I know exactly what it is that I'm looking at. You can flip them backwards. It doesn't really matter, but the only thing is the more lines that you have, the more confusing it is to look at because it may cross with one and not others. So you want to click that. Make sure you press this add button, and it will come up here, and it just shows you that they're going to graph the interaction between job category and gender. If you guys want a line chart, the bar chart won't be as helpful in this case. And you're going to press continue. And then you have your univariate options. Make sure you check off your descriptives, your estimates of effect size, and your homogeneity tests, and continue. Your significance level will be preset for you, so just make sure that it's there, but it shouldn't have any issues. Okay. This is the exact same as t-test. So this is your Levene's test for homogeneity of variance. This is one of those counterintuitive things, right? We want the p-value for homogeneity to be greater than 0.05. So what you'll notice in this slideshow, as well as the other one, is that p less than 0.05, homogeneity violated. P greater than 0.05, satisfied. Make that determination, let us know what it looks like. In the event that it is violated, you have 2 options. You can use a more stringent p-value or proceed as planned with it as a limitation. I would strongly recommend going with option 2 for the purpose of your final exam. It'll be a lot more straightforward for you. It could be satisfied, I don't know, I haven't run it. But in the event that it's violated, just let us know there was a violation. It may limit the results, and that's it. You guys aren't necessarily looking for anything else to do. This is sufficient enough for your final exam. The only thing that's different from your t-test is where you find this information. So you will be presented with this table, and it has a whole bag of different options here. Just use your based on the mean. It's always going to be at the top of that table for you to see. You'll see your Levene statistic and your significance. You don't really need your degrees of freedom for your Levene's test. Just make sure that you guys are giving us your Levene statistic value, so 33.383. The significance, in this case, it is statistically significant, so there is a violation, but we're moving forward as planned, and we're going to acknowledge that there was a problem. Okay, we got it color-coded and everything. So basically, this is what's gonna come out. You're gonna get this big table, and there's a whole bag of options again on the left side. The cool thing is the variables are already labeled for you. So when you go down and look for it, you should have an idea as to where things should be that you're looking for. So here, in the analysis example that I ran, I had job category and gender. When you come down here, you don't need your corrected model, you don't need your intercept, your error, your total, or your corrected total. Your three of interest are in the middle. You have your job category, your gender, and then the asterisk one, which is this third one here, is the interaction. For those of you not familiar, when you guys are coding or you're using statistical software, your asterisk doubles as an X or a multiplication symbol. So when you see that, it's safe for you to say, okay, the interaction between gender and job category. So there are three things that you guys will be interpreting for your two-way ANOVA, okay? What you guys will notice is that the effect size is different. It's not Cohen's d, it has different cutoffs. This is called partial eta squared. It's the same concept, it's the same effect size kind of situation, but 0.01 is small, 0.06 is medium, 0.14 is large. Cohen's d was very, very different. Make sure that when you guys are comparing and you're looking for your measure of effect size, use this chart. So, what's going to happen now is I'm going to go through and show you how to interpret your main and interaction effects. If my markers die, I'm sorry, I'll try and find another one. But essentially, we were looking for, why is this here? Okay. So we have a main effect of, what's the first one? Job category. We have a main effect of gender. And you guys have an interaction. Obviously, this will be different for your final depending on what it is the question is, but know that you will have two main effects and one interaction effect. So, what you guys will notice is that we need that test statistic and a p-value to decide your null hypothesis stuff, this stuff, right? So we want to get our specific test statistic, which is our F value, and our P value. So that's the first thing that you want to do. So for job category, 182.782. So F equals 182.782. Our P value under the significance column is less than 0.01, 0.001, sorry. And then you need your effect size, which is your partial eta squared column, which is on the far right column. So 0.483. You guys can write it out, it doesn't matter, partial eta square, or you can put, it's like an N, like a fancy N, and it's 0.438. Okay, does that make sense? Everybody knows where I get that value from? Coolio? Awesome. You're gonna do the same thing for your gender. So you have F equals 59.359. P value is also less than 0.001. And then you have your partial eta squared sitting at 0.112. All right, and then we have our interaction. Same thing, we want the F, the P, and the partial eta squared. Your F value is 14.114. Your P value is also less than 0.001. And your partial eta squared for your interaction sits at 0.029. 0.029. Okay, so these are the statistics that you need. So as you guys can remember, going through your assignments, you get statistical interpretation marks, and substantive marks. These are the numbers that you guys are going to be interpreting. Does that sound good? So what I'm going to do is I'm going to go underneath each of these different components, and I'm going to write it in green so you guys know like what each of the numbers mean. So we'll start with the main effect of job category. We have an F value of 182.782, P less than 0.001, and your partial eta squared of 0.438. Our P value is statistically significant. So it is significant. Coolio. What we're going to do now is we're going to look at our partial eta squared, and we're going to compare it to the chart on the top. 0.438 is obviously way bigger than 0.01 and 0.06. If your threshold for large is 0.1, 0.4 is obviously a lot larger than that, so we can go with large. If you want to say very large, that's fine too, but we know that there is a large effect. We're going to do the same thing for gender. This P value is exactly the same, statistically significant. Partial eta squared sitting at 0.112. It's a little bit less than 0.14. However, it's basically double what the threshold is for medium. Use your discretion, but in the event that you're not sure, you can say medium to large. In this case, I would argue that it would be large because it's only off by like 0.00 something. So we'll go with large. And then same thing for your interaction as well. Your p-value, obviously it's exactly the same, statistically significant. Partial eta squared is 0.029. So it's obviously not large. It is sitting somewhere between 0.01 and 0.06. Given that it's right in the middle, I would probably argue that it's small to medium. So the effect is small to medium. Okay? Is that making sense so far? So when we put all of these components together, we're going to analyze it literally one by one. So the first one is your main effective job category. You're literally going to walk it over, and it's kind of like sounding it out almost, each of the different components. So we're looking at the main effective job category. There is a statistically significant main effect of job category on the dependent variable in my example is current salary. So that's what we're going to go with. So there's statistically significant difference for main effect of job category, and it's a large effect. So basically what that means is that depending on your job category, your income is going to significantly differ. Does that make sense? Going to do the same thing for gender. There is a statistically significant main effect of gender. The effect is large. There is a statistically significant interaction between gender and job category, and the effect was reduced in size and it's small to medium. Okay? Does that make sense? This is your statistical stuff. Basically what happens after this would be if you had more than 2 groups. If you had 3 groups, for example, which I do, so I didn't run the post hoc, so I didn't want to scare you. But basically, you would interpret your post hocs to see where those differences are. But you guys remember from t-test, there were no post hocs. You guys looked at your descriptives, right? So what I'll do is I'll give you an example of what a substantive interpretation of this information may look like. I don't have the stats up here because I don't have my descriptives table, but I know you guys know where to find that, so you're good. So basically, we'll call it men and women for gender, and we'll call it managers and non-managers for job category. Okay? So basically, la-di-da, when you look at your statistics, you'll see means, right? Your average salary, right? So in this case, we'll say men made an average of 80 grand and women made an average of 60. For managers, we'll say an average of 100 grand and then an average of 75 for non-managers. I'm literally making these numbers up in my head you guys will have the descriptives to tell you exactly what the mean was, okay? So, when you guys have this information, right, these correlate. So basically, I'll start with gender because I put it on top. Gender. There is a statistically significant difference in current salary between men and women, such that men make significantly more than women, right? Because 80,000 is bigger than 60. Job category. There is a statistically significant difference in current salary based on your job category, such that managers make significantly more than non-managers. And there is a statistically significant interaction effect between job category and gender, such that who makes more? Male managers are likely to make more. Does that make sense? Is that all good? So basically, yeah.
Can you say that one more time?
Yeah, absolutely. So essentially when you guys are looking at your statistics, you're gonna refer back to what the information is telling you. So there is a statistically significant difference in current salary, which is your dependent variable, based on your job category, such that managers make more or significantly more than non-managers. These will be your average for your DVs, in this case, average current salary. For gender, there is a statistically significant difference in current salary based on gender, such that men make significantly more than women. And then there is a statistically significant interaction effect between gender and job category, such that managers make male managers make significantly more than female managers or non-managers. That make sense? It's color-coded here for you, but just remember as you guys go through, look for your variable names and the one with the asterisk. For a two-way, that's all you're looking for. No post-hocs, use your descriptives. And this is an example of what that information may look like when it's graphed. Ignore me because there's literally 3 categories. You guys will only have 2. So that's the only difference that'll be there. But what you'll see is that, there's my favorite, gender as your separate lines, male, female.
We should include that in our announcements.
Yeah, it will come out for you, and I know there's marks assigned to it, but I'll have to double check how many marks there are. Basically, you'll look at this and tell me what you see. So here you can see that managers make a lot more than clerical employees across both groups, but it seems that male managers make way more than everybody else regardless. You can see that those lines are crossing, there's an interaction there, right? So this is a lot more about when you're looking at it, does it corroborate your findings? Yes or no? What do you see? Tell us what you see. Okay, your next portion is regression. It's also worth 40 marks. We're not gonna go too deep into regression. You guys did an assignment on it. It is exactly the same. Different variables, but exactly the same. So reflect back on your regression criteria because I wanna go through the hierarchical regression stuff, which is a bonus question to kind of boost you guys up there. But we'll go through the material nonetheless. So with regression, if you guys can remember, it's assessing the strength of the relationship between an IV and a DV. It allows us to assess whether certain predictors can explain a particular outcome. How much variation can be explained in the DV by the IV, how much cannot, your R-squared, all those fun things. And it allows us to make future predictions about a case given an individual's observed score. So that would be our regression equation. If you guys can remember, y equals a plus bx, or if you use the other one, it's y equals beta 0 plus beta 1x. These are all of the statistics that you need to interpret. This should be reviewed for you guys based on your last assignment. You have your R-squared value. You multiply by 100 to get your percentage of explained versus unexplained variance. So if we had an R-squared of 0.3, 30% of the variance is explained by the model. The remaining 70% is unexplained. Your F statistic tells you whether it's significantly better at predicting scores than the mean, whether it was a good fit. We want it to be significant at the 0.05 level. In the event that it is significantly better at predicting scores than the mean. Your t-test tells you the significance of individual predictors. Was X a good predictor of Y? We want significance at 0.05 level. Your unstandardized betas tells you for every unit increase in X, your independent variable, there's going to be X increase or decrease in Y. So like I said in the regression class, I believe we talked about like height and weight. So for every inch increase in height, you may gain 1 pound in weight because of bone density, right? You need more bones to hold tall people up. That's what it is. And then you have your regression equation, which is allowing you to create a formula to predict future scores. You have your y prime, which is obviously your dependent variable. You have your a value, which is your constant, which can be found in your coefficients table. You have your beta value, which is your slope, your unstandardized beta, which is also the thing that tells you for every unit increase. And then you have your x, which is your observed value for your independent variable. So in the event that you are provided with x, you can do the equation to get the predicted y value. In the event that you're not, that's fine. Just write it out. Let us know what's up. So we know that regardless, you guys are going to have a constant. You guys are going to have a beta value for the variable that you're looking at. You may or may not be given x. If you are given x, input it and do the math. If you're not given x, that's okay. Just put your independent variable. Same thing for y. You're obviously predicting it. It's not going to come out unless you're given x, which is okay. In the event that you're given it, you'll do the math and you'll come out with a y value. In the event that you're not given it, just write the name of your dependent variable. Same procedure as your regression assignment. Okay.
Which assignment was that? Was it 3? 1, 2?
Yeah, assignment 3. Okay, so your final exam gives you guys the opportunity to earn bonus marks. I love some bonus marks, to be honest. But the cool thing about bonus marks is that if you try this and you nail it, you get 10 marks. If you try it and you mess it up, nothing bad happens. Like, it's literally just an opportunity for you to earn more. If you guys are, like, if you flunk this completely, it's totally fine. Like, you tried. And what we like to do with this is go through and try to give you as much as you can. I would highly recommend you guys give it a shot. There's nothing to lose, other than a couple minutes of your time. But you're already writing the exam, so it doesn't matter. So, like, I'm gonna teach you guys how to go through it. Strongly recommend you give it a shot. Best case scenario, you earn extra marks. Worst case scenario, you don't earn extra marks. This has no impact on the rest of your exam. You guys can choose to do it or not do it. It's totally up to you. If you want an opportunity to get more marks, give it a shot. It's not going to be as intimidating as you guys think, and I'm going to literally walk you guys through it. Okay? It's an opportunity for 10 marks. But what I will tell you is that because it's 10 marks, oh, these markers, man. I need new markers. Because it's 10 marks, typically a hierarchical regression would not be marked out of 10 marks. Like your assignment for regression, for example, was out like a lot of marks, like 100 marks or something, right? There's a lot of different components. So the thing is, it kind of has to be correct to get the marks. Because I can't really give you like 0.25 out of like 1, because that'd be weird. But I will do my very best, and Fumi will do her very best to find the areas where you guys have earned marks, and it's bonus marks. So you can't go wrong. Oh, Jesus. We're gonna pretend like that's gone. All right, so it basically follows the same procedure as your standard regression. It's still assessing the strength and relationship between an IV and a DV and making predictions about future cases. So that's all the stuff that we just reviewed, right? However, what it allows you to do that's new and different from a regular regression is you're entering variables in blocks. So it's like steps in a hierarchy in order of importance. Usually when people run hierarchical stuff, they've read a crap ton of research and it says, this is the best predictor. This is a good predictor. This one we're not too sure, kind of stuff. So you're able to see that based on previous research, somebody may have like a really, really robust finding that this is always really good. This is always pretty good. And we're not really sure about where this one lies. So basically, an example of this would be predicting depression. We know that one of the best predictors of depression, just as like a worldwide fact, fun factoid if you didn't know, is that it's anxiety. So the presence of anxiety in a person basically increases their chance of developing depression. They're very, very strongly related. They affect similar inner workings of the brain, etc., etc. So we know that anxiety typically predicts depression. Something else that may predict depression, which is usually associated with depression, is sleepiness. A lot of times individuals that suffer from depression often find themselves very fatigued, they have trouble getting out of bed, etc., etc. We know that that may be a good predictor of depression as well. And lastly, we have gender. If you guys are unfamiliar, women are statistically more inclined to develop mental illness than men, which is what it is, I guess. But we would be safe to say that essentially being a woman by nature may make us more susceptible to developing a mental illness than a male would. Not to say that males can't have mental illness, but statistically, just based on genetics and all that fun stuff, we are more likely to have those particular conditions. So that may also be a predictor of depression in a person. So, what's going to happen is you guys have already been given an independent variable. You guys have already been given 3 independent variables. I don't remember what they're called, but I'm going to walk you through this one. So you'll be fine. So we're going to go to Analyze, Regression, Linear. And we're going to be prompted with this block screen, which I'm pretty sure is exactly the same as a regression screen, because I ran one yesterday and I was like, oh, look at that. So basically, you're going to move your dependent variable into your dependent box. But I'll do the statistics box first. Statistics, you check all of these boxes and press continue, and that's it. So, when you have to put in your independent variables, right, they obviously go in here, this big box. But what you'll notice is that at the top of this big box, it says block 1 of 1. Psych, we're using more than one block. That's about it. So basically, you're going to enter the variables in order of your hierarchy. So basically, what that looks like, block 1 is going to be your strongest, most consistent, whatever we think is going to work the best. That information will be provided to you. In my case, we know that anxiety is the strongest predictor of depression. Anxiety is going to be the first thing. Block 1 has anxiety in it. Block 2 is going to be adding something to our model. So whatever the effect of anxiety is, it is what it is. We know it's going to be good. Sleepiness is when we start to get a little bit confused. We're like, I'm not really sure. Will it be coming out significant for my sample? Let's look at it. So, block 2 would be the effect of anxiety and sleep. That make sense? So now it's 2 variables. And then block 3 is the only one we're missing is gender. We want to look at anxiety, sleep, and gender. Right? So you have 3 variables in your final model. What that means for this portion is that you need 3 blocks. 1 block with just anxiety, 1 with anxiety and sleep, and 1 with anxiety, sleep, and gender. First block, you put it in. You can use your arrow button or you can force click, either one's fine. Once you have block 1, which should just be 1 variable, your most important variable, hit next. It will save it, and it will prompt you with block 2 of 2. In block 2 of 2, you are going to move anxiety back over again, and you're going to add sleepiness. Next, block 3 of 3, anxiety, sleepiness, gender. Does that make sense? A good indication of whether or not your information was saved and you're doing it correctly, this will change to reflect that information. So if you just add all 3, it'll literally say block 1 of 1, and you're only testing 1 model with 3 predictors. If you do 3 blocks, you're doing a hierarchical regression of 3 different hierarchical measures. You're going to go to plots as well. This is where your assumption stuff comes in, but it's not so important for your bonus questions, I should say. But basically, it's exactly the same. It doesn't look like English because it's not. They're basically plotting Z predicted scores and Z residual scores. So Z residual goes on your Y, Z predictor goes on your X. You're going to ask for a PP plot, press continue. Then we're going to head over to our save box. You're going to check off Cook's distance. If you guys can remember, that helped you guys out with outliers in the past. You're going to press continue. This matrix thing will already be checked off. Okay. So that's it. All of your information will basically be saved, but this is just showing you that, okay, look, 2, right? So essentially, just make sure when you guys are going through and doing your blocks, it saves that information. So your first block is just anxiety, your second block, you're actually only inputting sleep, and your third block, you're only inputting gender. The system programs it to compare all three. So one variable per block is added here, but in the inner working of the system, you guys are adding multiple to your model. So block 1, you add anxiety. Next. Block 2, you add sleep. Next. Block 3, you add gender. Next. And your output will do a model with anxiety and sleep, and the last one will be anxiety, sleep, and gender. Does that make sense? So just make sure when you guys are putting in your blocks, only add one variable at a time, because the system sets it up for you. If you make a mistake, it's got a previous and a next box, so you can double check what you've got in each box. Yeah, so that's what it looks like. Block 1, block 2, block 3. Okay, so you already know how to interpret this information. Whether you guys choose to screen for outliers before or after you actually run your regression will affect how it is that you decide to do that. Totally fine, either one, doesn't matter. But for those of you who may not be able to remember, we get a case-wise diagnostics table that comes out, and it gives us standardized residual values. If it is greater than 3, which only cases with standardized residuals greater than 3 will be put in your case-wise diagnostics table, everything with a standardized residual greater than 3 is an outlier. In the event that you have outliers, that's okay. We're going to go to our residual statistics box and take a look at Cook's distance. If you guys can remember, if it's greater than 1, it's a problem. If it's not a problem. So basically, you're going to look at your maximum and see, okay, is it greater than 1? Nope. Perfect. It's all good. You can leave all those outliers in, which basically means they're not having an undue influence on your analysis. In the event that it's greater than 1, what it will show you is that you need to go to your case-wise table and take out all of those cases. It gives you the number, you just delete it, and you're good to go. These are the visuals that will come out. You don't really have to worry too much about them for the bonus questions. But you have your PP plot for normality, and you have your scatter plot for your heteromoscedasticity. Okay, guys, you can do it. I know you can. So your correlations, you don't really have to interpret that for your bonus questions at all. Same thing when you guys did your regression. The correlations table comes out for you, but you don't actually have to interpret it. It's like a little peek in to see what's going on, you know? So basically, it's basically telling you the strength, direction, and magnitude of the relationship between the variables, but you don't have to do too much with it. You can look at it if you want to, you don't have to include it. This is the stuff that you have to include. Okay, this is all the stuff that you have seen before, okay? We're just gonna go through it step by step by step by step by step. There's just a lot of things to report, but it's all things that you're familiar with. So the first thing, I know you guys know this one because you guys do great with it, is your model summary, your R squared, right? This is the one that we multiply by 100 to see how much variance is explained versus unexplained. Something that you will notice as you guys go through this particular set of results, there's 3 of everything. You guys ran 3 tests. You have 3 blocks, 3 different measures of your hierarchy. That means there's 3 sets of 3 things that you have to look at. We'll start off with this top box. This box is circled because it's cool information. You don't have to report it though. It's just there. So basically what it's telling you is your change in R squared and your F change. So basically, by adding variables to your model, how much more variance is explained or unexplained, and how much did the impact go up or down for your F value. What's important from this table is your R squared and your adjusted R squared. As you guys know, rule of thumb is always report both of them, but you're doing the math on the R squared. The adjusted just applies corrections for you, but when you're actually doing the information, like the math that you want to use your regular R squared. So the first one is 0.326. So that means 32.6% is explained by anxiety alone. Does that make sense? Block 1, 32.6%. I took 0.362 and 226. Oh, Jesus. Math. Yeah, 326. And multiplied it by 100. If you want the unexplained, you guys would take 100 and subtract this number. I think it's like 67.4 or something. Either way, You guys would want to do that math, but I don't have the brain power this morning, so you guys are welcome to give it a go. Block 2, you have 0.331. So that's 33.1%. 0.1% is explained. A little bit of an increase, which is kind of cool. So when you guys add sleepiness into the model with anxiety, it explains an additional, about a 1% more variance. Same thing for your third model, which is also known as your full model. You have 33.4. It also went up a little bit, right? So, that's step 1. List your adjusted R squared and your R squared values. Tell us how much variance is explained, how much is unexplained. This needs to be done for every single step, so 3 times. It's super redundant, but there's very slight differences, as you guys can see, right? 32.6, 33.1, 33.4. Small differences, but those differences matter. The next thing you have to look at is your F and significance values, your F and P's. Once again, there is one for every single group. So there's 3 that you have to report. It's redundant, but it matters. So basically, you're going to go through again and do the same thing. You have an F statistic for block 1 of 116.899, 116.899, and then you have a p-value of less than 0.001. You're going to do it for block 2. Your F value is 59.691. 9.691. P-value, yeah, also less than 0.001. Okay. And then the F value for your final model, 40.159. Okay. If you guys can remember, from reviewing your regression information, we now have our model summary, which is our R squared values, and now we have an F and a P. That tells us, is it significantly better at predicting scores than the mean? Yes or no? These guys are all significant, which is awesome. So we know that block 1, just anxiety, is the model is a good fit, is significantly better at predicting scores than the mean. Significantly better at predicting scores than the mean, significantly better at predicting scores than the mean. Basically what that's telling you is that as you add things, the model's getting better. Not by much, but it's getting better. Is everybody following so far? Yeah? Okay. Now, this is the actual output for your hierarchical regression. You guys know how to interpret this. It's the exact same thing with a whole bag more rows. So we basically just have to figure out what rows we want to interpret. So essentially, the only difference with this table is that it's not going to be as redundant. We are only reporting what we call our final model, which is number 3, with all 3 variables in it. You can see here, it's model 3. It has constant, anxiety, sleep, and gender. If you look up, they get smaller, but missing stuff, right? So, what we got to do now is interpret that information. It's going to take me a hot second to write it all down, but that's okay. So basically, the first thing you want to do is look at your t-value and significance, right? We're only reporting model 3, so I'm going to split it up into each variable. Is that cool for everybody? So we have anxiety, sleep, and gender. All right. So I like to start with my t-values because it always tells me, is it a good predictor, yes or no? Just tells you the importance of the overall. So for anxiety, there is a t-value of 10.408. T equals 10.408. And the significance is less than 0.001. And then you have CIs as well, which is 0.4, 0.5, 0.4. Does this look familiar for everybody? Coolio? Awesome. Okay. And in addition to that, we have our beta value. For anxiety, it's 0.493. So B equals 493. Okay, same thing for sleep. Get all of your statistics lined up, because then that way you can kind of do that like the sounding it out thing. We can follow it, track it across, and it makes it a little bit more cohesive for when you guys write it all out and interpret it. T-value for sleep is 1.512. 1.512. Okay, P-value. What you'll notice is P for this one is 0.132. That is bigger than 0.05. You can either write it as P equals 0.132 or P is greater than 0.05. Synonymous, doesn't matter, do what's best for you. You have your CIs, which is negative 0.02 and 149. And then a beta value of 0.065. And then the last one, gender. You have a T value of 1.031. You have a P value of 0.303. Same thing, you can do P equals 0.303 or P is greater than 0.05. You have your CIs, negative 306, negative 0.306. Oh my God, my marker is dying. And then 0.977. And then a beta value of 0.336. Everybody following so far? Same process. We're doing the same thing. So now that we have that information, now that we have this information, we can make conclusions about what's here, right? So first things first, we have a T value and a P value. Your T value tells you, is a significant predictor, yes or no? P, statistically significant. So we have a significant predictor. What this also tells you is your beta value. So for every 1 point increase in the depression scale, the only reason I'm like sounding this out right now is because it doesn't have units, my example. They're standardized scales. So basically, if anybody has ever gone for testing for mental health, or if you're not familiar with it, they basically give you a sheet of paper and they're like, okay, circle. And then once you've circled it, they go and they tally up the scores. So basically what that means is if you meet a threshold, you definitely have or do not have this mental illness. So for every 1 point increase in the anxiety scale, there is a 0.493 point increase in the depression score. Does that make sense? Depression is our outcome. Right now we're looking at anxiety as our independent variable. So 1 point increase in anxiety equals 0.493 increase in depression score. Okay? Next one. Sleep. T and P. Is it a significant predictor? Nope. P is greater than 0.05, right? So unlike this, it's not statistically significant. So it's non-significant. However, you can still make this conclusion because what you'll notice is that as you interpret it, you're like, wow, it's not really doing too much, which is exactly what this is telling you. So for every 1 point increase in the sleepiness scale that was used, there is a 0.065 point increase in depression. If you guys compare 0.493, this is half a point. This is like not. It's very small. So you can see why it may be non-significant. Gender, same thing. T value, P value. Statistically non-significant. It's greater than 0.05. So you have a non-significant predictor, but 1 point increase. Oh, okay, this is another fun fact. Gender is male and female, right? Were you guys introduced to the concept of dummy coding? No? Okay, that's okay. I don't think you'll need it on your exam, but for the purpose of my example, unfortunately, you need it. Basically, what dummy coding is, in short, is turning a nominal ordinal variable into a variable you can use as a number. So it's transferring it from nominal ordinal to continuous. Does that make sense? How you do that is by assigning the conditions the values of 0 and 1. So whatever they did, they picked 0 and 1. How they coded it, I don't know, but we're gonna call it men 0, females 1. When you dummy code something, when you give it the value 1, that is your reference group. So basically, in simple terms, what that means is when you interpret that information, you're interpreting it in the context of females. Does that make sense? If we have females graded as 1, females are the reference group. So we're interpreting the findings in the context of women. If it was flipped, it would be men. Does that make sense so far? So basically, what this means is that women, because they're coded as 1, so women would have a 0.336 point higher scale score in depression. Does that make sense? If it was flipped, if it was males were scored as 1, it would be men have 0.336 points higher of a score in depression. Does that make sense? I'll double check and see if yours is dummy coded, but I don't think it is. But you shouldn't have to worry about it. So, this is your interpretation, right? This tells you, is it a significant predictor? How much of a change is there? It even gives you your CIs, so you have that information to interpret as well. The last piece of the puzzle is your regression formula. Exactly the same as before, but the only difference is you guys have added 3 variables to this model, right? So we need to account for that. So, your original model is y equals a plus bx, right? That accounts for, in the context of this question, anxiety. That's literally it. Just the one variable. There is 1 spot for a beta value and 1 spot for an observed value. However, we added 2 more variables onto that. So what's going to happen is our formula is going to expand from this to cx plus dx. Quite literally, we're adding 1 option for sleep and 1 option for gender. Does that make sense? You guys fill this in exactly the same way. Exactly the same. So, when you look at it, you have your y value, which is depression. That's our dependent variable. We have our constant. Remember, we are only looking at our final model. So it's model 3. It's in the red box. Constant is negative 0.219. Negative 0.219. Now we have anxiety with our beta and our x value. So basically, we need our beta value, 0.493. 0.493x. In this case, it would be an anxiety score. Next one we need is our sleepiness. We have a beta value of 0.065. 0.065x. In that case, it would be your score on the sleepiness scale. And the last one you have is 0.336 for gender. 0.336x. In that case, you would either input a 0 or a 1, depending on how it's coded. Does that make sense? So yeah, that's how you would come up with that formula. It's literally just a longer version of regression. Quite literally, hierarchies, literally just a longer version. You guys are very familiar with this. You guys perform very well on your regression, so I'm confident that this is a good opportunity for you guys to gain bonus marks. If you want to do it, do it. If you don't, don't. I would encourage you guys to give it a shot. Worst case, you just don't earn extra marks. We aren't going to be deducting marks for anything. It's solely just a good faith, give it a go. Okay? Disregard April 15th, I was told it was April 10th. So, I'll change that. But, important reminder, you're expected to carry out all relevant data screening. I'm gonna go over the rubric and tell you what we want. It's obviously gonna be a little bit less because it would be ridiculous to have you do it 4, 5, 6 times. We are expecting you to interpret your results and summarize your findings. So it doesn't stop at the numbers, okay? You need to put your statistical interpretation, which is all of the numbers, and then hit us with the words too. If you're gonna give it to your mom or your dad or your sibling that has no idea what you're talking about, we need a version of that that is understandable for other people, okay? Final exam is due April 10th, and plagiarism will not be tolerated. You guys are able to work in groups, you're able to work in partners, whatever it is that you want to do, whatever it is that gets you the best on this exam. We don't mind how it is that you do that. But your answers need to be uniquely your own. You are welcome to use the slides to guide your interpretations. If you need pictures of this, I don't care, take what you need. But make sure that when you guys are writing it out, that your responses are worded differently, if that makes sense. All good? Coolio. Okay guys, we did it. So I will pull up the rubric now so that you guys know exactly what's going on. Yeah, okay. So like I mentioned, for the NHST and confidence interval question 1, 20 marks, split down the middle, right? First half of the question, what can you conclude based on the results, right? So your t-value and your p-value, that's all that you have. What are you missing? We went over that at the beginning, right? So 10 marks, tell me what you have. Is there a significant difference? Is the null hypothesis accepted or rejected? What does the p-value tell you? And if you really want to like spice it up a little bit, you could even like put it in the context of the question. So like whatever it is that, I don't know what the context of your question is, but like if you're looking at the significant difference between men and women, you can say there is a statistically significant or non-significant difference in current salary for men and women. Throw a substantive interpretation in there. Do what you gotta do, but know that it's 10 marks. So make sure when you guys are reading it out to yourself, ask yourself, is there anything else I have to put here? Is there anything else I'm missing to make this a 10-mark answer? The second half of the question, what other approaches to assessing this data would you recommend and why? 10 marks. We are not expecting you guys to tell us what test you should run. A test has already been run. It's more so what's missing from those values that could lend important information, and what can they tell you? Does that make sense? Yeah.
What is it again? Can you say it? What
Yeah.
other approaches?
So you're not expected to do any other testing, for example, but it's more so what you're missing. So NHST doesn't tell you about the size or the meaningfulness of the effect. Your job is to figure out what test you can run to get that information. Coincidentally, the answers are in the first bit of the slide. Does that make sense? Cool, yeah. Okay, question 2. This is your 2x2 ANOVA. This is the new stuff. It's worth 40 marks. Data screening is worth 5 marks. So, for data screening here, all that's being expected of you is to do missing cases, outliers, and skewness. So check for missing cases, check for outliers, and check for skewness. So that's your histograms. You need 1 per variable. That's nothing new. Paste the output. I want to see it. And let us know. Is there any problems? Is there not any problems? If there is any issues, like if you have outliers and missing data, are you Windsorizing? Are you filtering? Are you deleting? And why? Does that make sense? Okay, the actual ANOVA stuff is worth 35 marks, obviously. Your Levine's test is worth 2 marks. So, give me the statistic and tell me, is it significant? Yes or no? Is that a violation? Yes or no? Okay. So, next is your between subjects effects testing. This is where we have to interpret each of the relationships. If you guys can remember what I had on the board, you have 2 main effects and an interaction. That's 3, right? I need the F and the P value for each of those relationships, as well as your effect size. And you gotta tell us, like, is it significant, yes or no? How strong is the effect? Weak, moderate, strong? And you also have to tell us for, like, is there a significant difference? Yes, okay. So in my example, there was a significant difference between, like, for incurrent salary for men and women. Okay? So you would go farther, take those numbers and put it into a little bit of words. You have your effect sizes, which I mentioned just now. That's all worth 20 marks. So basically, it's 20 divided by 3, right? There's 3 different relationships you need to examine, so there is, give or take, a little less than 10 marks per statement. You have 5 marks attributed to your graphs. If you click all the buttons that are on the slides, the graphs will pop out for you. So basically, paste the graph in, like just the graph, and let us know what it is that you're seeing. There's 5 marks here. You get marks for the output, but you also get marks for telling me what's going on in the graph. Are the lines crossing, yes or no? Based on that, do you think there's going to be an interaction? Do you think it's a strong interaction? Who's making less? Who's making more? Or what scores are higher, what scores are lower, and for what condition, etc., etc. It's literally 5 marks for you to tell me in depth what you see in that graph. And then lastly, you have 8 marks for a conclusion. So basically, you need to sum everything up. And this is where we do it in words, right? So we're not really going to focus on our numbers here. This is the stuff that you're going to give to your mom, to your dad, to your brother, to your sister, anybody, to make them understand. So talk about significance. Talk about the size of the effects. Like, was it a strong effect? Was it a weak effect? What's your graph show you? Does that make sense? Okay. Question 3. We have your regression. I'm going to breeze through this one a little bit because you guys have pretty good experience working with your plane regression. It's the exact same kind of expectations as your assignment. 40 marks. Your data screening is worth 5 marks. Same thing for the screening. Missing cases, outlier, skewness. We're keeping it pretty basic. If you found a problem, tell us what you did and why. Your regression itself is worth 35 marks, okay? Your model summary, which is literally your R squared, your adjusted R squared, and the variance explained and unexplained. So like this stuff, I want to see the value as what it is before you multiply it, and tell me after you multiply it how much variance is explained versus unexplained. It is 15 marks. That's like one sentence for 15 marks. Just make sure you got everything. I know that you guys can do it. You guys have shown me time and time again that you're good at it. Yep.
Can you repeat that section again?
Yeah, absolutely. So your model summary is your proportion of explained variance. It's worth 15 marks. You guys should have your R squared value and your adjusted R squared. Just remember when you guys are actually doing the math to figure out the proportion, use your plain old regular schmegular R squared. It's the regular one. And you'll tell me how much variance is explained by the model and how much remains unexplained. 15 marks. The next portion is your ANOVA, which is your F statistic. It's worth 5 marks. So here, I need your F value and your P value. And you're basically telling me, is the model a good fit? Is it significantly better at predicting scores than the mean? Yes or no? That's 5 marks. Next up, you have your coefficients, which includes your T's, your P's, and your betas, and your CI's. So literally everything that's here. These are the numbers that you're going to need. It's worth 5 marks. So just make sure that you have your T value, your P value, your corresponding CI values, and your beta values. And obviously, you guys want to tell us what that means. So like for every unit increase in X, there's extra unit increase in Y, decrease, whatever it is. And then you have your regression formula, which is 5 marks. So yeah, so I literally, like, I don't see any X values. I don't think you guys have to do the math. So basically, for this question, it would be the first part of this formula, right? Y equals ax plus bx. Put the blank formula and then fill it in. Obviously, you guys are not given any x value. You're not expected to do the math. Put in the independent variable name. I have to know that you guys know what would go there, is basically what it's saying. So put that in. Show us what it looks like. And then you have 10 marks for your conclusion. So this would be things like, was it a large amount of variance that was explained? Was the independent variable a good predictor? Yes or no? How can you predict other scores? Maybe put the formula in. And I know that your question is phrased as kind of like an exploratory endeavor. Refer back to your question and see if you can answer anything that the hypothetical person was trying to do. Okay. Last one is your bonus question. You guys can try it, not try it, your call. I'd recommend giving it a try, but hey, it's up to you. So like I said, it's a little bit more difficult to split stuff up here because it's literally 10 marks. So like all this stuff we did is literally 10 marks. So it's a lot. But you get 1 mark for data screening. Same procedure. Outliers, skewness, and missing cases. If you found something, let us know what's up. Let us know what you did to fix it. Okay? You need to use your use the hierarchical regression correctly. So that means you need 3 blocks and you have to put it in the right order. That's worth 1 mark. So in this case, you would get 1 mark for putting your regression is as block 1, block 2, block 3. Sound good? So you guys have to decide what variable is most important. That one comes first. Which variable is second most important? That one comes second. And what variable is third important? That one comes third. You need your R-squared values at each step of the model. It's worth 1 mark. That's these values. Your percentage of explained variance. You need your F values and significance at every step of the model. That's these values. That will tell you, is that block a good fit? Is it better at predicting scores than the mean? You need your T values, P values, and beta values, as well as your CI. So all of these fun numbers, it's worth 2 marks. So you have your betas get 1 mark, and then you get your T, P, and CIs count as 1 mark. And then you need to outline your final formula, which is this over here. Make sure you're including all 3 variables. Make sure you're reporting all these numbers. You should be coming from your final model, right? Model 3, it's got all 3 variables in it. And then lastly, you have 3 marks worth of a conclusion. So what do the results tell you? How much variance was explained? Which predictors were strong? Which ones were weak, if there were any? What formula can you use if you wanted to predict future scores, etc., etc. Best case scenario, free 10 marks.
Yeah, sorry, can you repeat that?
Yeah, absolutely. So for your conclusion, you guys want to include things like, was there a large amount of variance explained? Yes or no? How much variance was explained? Which predictors were strong and which were weak, if there were any weak ones? If you wanted to predict future scores, what formula would you use? Which you guys will already have had since you did it for part of the question before your conclusion. And if you can, you can relate it back to the question. If you can find anything to address that has been answered with this information, you're welcome to do so as well. Okay. And that's it. It's due April 10th. Fumi and myself will be grading your final assignments. So I feel like it's gonna be 1 per section. She's gonna have 1 section, I don't know. But we're gonna be grading your assignments. Your final exam grades will not be visible to you, I don't think. In the event that you guys wanna know how you performed, please reach out to Dr. Eastwood after the release of final grades and only after the release of final grades if you wanna know specifically what you got on your final exam. You guys should have assignment 4 grades, hopefully by this weekend, so you should have a pretty good idea as to what you're going into your final with. Your final exam is worth 40% of your grade. You have the opportunity for 10 bonus marks, which is super awesome, really great opportunity to kind of boost your mark there. I'm obviously available for questions, comments, concerns. If you also have questions regarding grading or anything like that, you're welcome to contact Fumi. Just omit Karina because she's not grading them, so she might not be as helpful with that respect. But yeah, I'm here like to offer support to you guys throughout the writing of your final exams. The one thing I will note is that my feedback will become more vague just because it is your final. With your assignments, it's a little bit different. I have the opportunity to kind of coach you through it, but I will still support you. I will still answer your questions. You guys are welcome to ask via email. We can set up calls, whatever.